Okay, so let me ask you this. If you do you have any questions in previous session? Is that clear?
No, I don't.
Okay, good. So today we'll be looking at the remaining topics, like we were about to see the look and feel of the screen and what are the different tools that are part of data services. So we'll be looking at that today. Alright, so the navigation for data services, to log into the data services
Uh,
designer.
um, I think I need to call in. 1 second. I think I need to call in because I
Mm-hmm.
think I still have that same old problem. So give
Okay.
me 1 second. Let me call in.
Mm-hmm.
Yes, Rakesh?
Yeah, Kofi.
Okay, I'm back in.
Alright, so yeah. So to log into the data services designer, the navigation is Start, Programs, Business Objects, Data Services, and Designer. So this is the place where we generally, as a data services consultant, will log in and work. So if you click on this designer, it will take you to the logon screen where you have to key in some credentials, and then it will take you into the designer. Alright, so this is my data services logon screen. Alright, so first you have to give the credentials and click on logon, and you will find the list of repositories here. So you can choose your local repository. For example, this is my local repository underscore batch 1, and just click on OK, and it will take you to the designer. So I'll tell you how to create this local repository and how do we view all those credentials for that local repository in a bit. So before that, I will like to explain this designer so that we can go into that local repository creation, which we call it as setting up the system. So this is the initial screen when you get into the designer, and it is divided into 3 areas. One is your project area, second one is your local object library, and third one is your data services logon screen. Okay, so the project area is again divided into 3 regions, which is designer, monitor, and log. So designer holds one project at a time. So if I open a project, so it holds a project, and project is nothing but a collection of related jobs. So if you look at this is a project, and these are all the related jobs that are present in that project. And when you execute any job, you can see the execution statistics happening here in the monitor. If a job is successfully executed or if it is a failure, you can see that here in the monitor tab. And the history of execution, you can see the history, how many times a particular job is executed, and all these things in the bad job logs. Alright, you can see all these things in the logs. And this is your project area, which you can detach from the screen and you can attach from the screen. Okay, based on your requirement you can do that. And next one is your local object library. This local object library is again divided into several segments. One is your projects. So why do we have project and project area and a project tab here at the same time? Because if you look at this project area can hold only one project at a time, but if you have more than one project in your local object library, those can be saved in your this one, local object library, under the projects tab. But the projects area will hold only one project at a time. Okay, and this projects, okay, so if you look at this description, it says projects here, or just let me expand so that you can see the complete descriptions at the bottom. So this is projects, which hold all the projects together. Project is nothing but a folder which contains the related jobs together. The second tab is jobs. So there are basically two types of jobs. One is your batch job and second one is your real-time job. So batch job is something that you deal with the structured information, and real-time jobs is something that you deal with the unstructured information like your XML data and stuff. So we'll look in more details when we start working on the jobs. Next, again, it's a workflow. Workflow is nothing but a folder where we group related data flows together. For example, I'm extracting data from 10 tables and I created 10 separate data flows. Now, all those data flows will be scattered here in my data flow list. So every time I want to search for them, I had to go and search for my data stores or data flows across all this list. So what I can do is I can group all my related data flows together within a workflow. So that's the reason why we need a workflow. So I can group all my related workflows, all my 10 extraction data flows in a particular folder called a workflow. So technically speaking, no logical stuff happens within a workflow. Workflow is nothing but a folder where you group related data flows. And next one is the data flow. So
Samo, could you please go over that? The line was bad. I didn't hear what you said.
Sorry?
Could you please just go over that? The line went bad. I didn't hear what you said.
Oh, you didn't hear that? Okay. So from here, workflow or from jobs? From where you want me to repeat?
From workflow.
Okay. Workflow is again a folder where you keep related data flows together. I'll tell you what data flow is in a bit. So technically speaking, no technical stuff or no transformations happen here. It's just a folder where we group related data flows together. Okay. Next one is a data flow. So data flow is again divided into two. One is your normal data flow and the second one is your ABAP data flow. So normal data flow is something where you generally do your business, right? So once you do an extraction, transformation and loading, so as I told you, data services is a ETL tool where we do extractions, transformations and loadings. So actual business happens within the data flow. So whenever you want to do an extraction, you use a data flow. Whenever you want to do a transformation, you use a data flow. So if, for example, just let me open one data flow here. So you see a source table and a target table, and we are connecting the source table with the target table. Alright, so just let me use one more this thing. So if you look at this, I have a source table here and I have a target table, and I'm using all these intermediate transformations to convert the data from the source format to my target format. So this is what happens within a data flow. The actual transformation or actual business or actual job is done within a data flow. So this data flow is again divided into two parts. One is normal data flow and ABAP data flow. So ABAP data flow is specific to SAP systems. When you are extracting the data from an SAP system and the volume of the data is more than 20,000 records, SAP recommends you to use an ABAP data flow, because this ABAP data flows will improve the performance. But technically speaking, I have experienced this. Unless and until the record count is not more than 50,000, there is no need to use an ABAP data flow. If the records count is more than 50,000, then definitely ABAP data flow usage will show the difference. Okay. So ABAP data flow, how it works means it will actually extract the data from the SAP tables and put them into a share folder on the SAP system, and from there the data is extracted in the form of a flat file. So that's how it improves the performance. We'll look in more details when we start working with that. The next tab is the transforms tab. Alright, so here you have this transforms. So we have a built-in transformations. So transformations is nothing but a pre-built code or a pre-built technology that is delivered along with the tool, which we can utilize. Instead of writing some coding, we can utilize these transformations. So if you look in the right side screen, all these things are our transformations, right? So all these things are transformations which help us to convert the data or which help us to carry out the business task. So these transformations are again divided into three major categories. One is your platform, second one is your quality, and third one is your integrator. Actually, this is the latest edition, TDP, text data processing, from 4.0 version of data services. This is nothing but a reporting tool which is used in business objects enterprise called Polster, where they actually read the data from a text paragraph and convert that into a table structure. So this is not that much use. So keeping that aside, if you look at the major categories of transformations, you have the platform transformation, you have quality, and you have integrator transformation. So if you expand the platform transformation, so there are some set of 7 transformations, and these 7 transformations forms the basic transformations for you to carry out any migration project. So if anyone is good enough with these 7 transformations, they can start working on a migration project, because even the SAP best practices utilize only these transformations to do the data migration. Alright, so we'll look in detail one by one when we start working with this one. Next one is the quality transformations. Unfortunately, we will not be looking at these quality transformations because these quality transformations require separate licensing, and that licensing again SAP will sell it to only registered partner companies. So we have a limit there. So one transformation is there within the data quality which can run without any licensing. That is the match transformation. We'll be looking at that. So the data quality transformation, this set actually takes care of the quality of the data. So if you have a bad data in terms of address or in terms of records, this data quality transformations will help us to cleanse the data or to improvise the data even though it is a record or it is an address. So you have some transformations like data cleansing transformations which actually will take care of the cleansing part. So what does we do actually in the cleansing? For example, we have a table where column 1, which is employee ID, that is marked as a primary key, and it has some null values. So this cleansing will tell us that a primary key column is having some null values which is not correct. So we can delete all those records and we can cleanse the data and take good data to the next level of the job. And for example, if I have address column which is not properly populated, so I cannot consider that as my solid information. So I need to cleanse that address so that I can standardize the address and I can call the data as good. So for that we have US regulatory address cleansing, which actually interacts with the address directories of US, and it will process the raw data that we are sending from our source, and it kind of converts that into good records and get it back to us. So this kind of quality assurance is done within the data quality transformations, and the third set is the integrated transformations. So these integrated transformations are the supportive transformations. Actual business does not happen here because you don't do any conversions or anything using these integrated transformations, but these integrated transformations help you to carry out the supporting activities. For example, the data transfer. So if you have huge volume of data, it will help you to split a single data flow into sub data flows, and it will try to improvise the process. Just give me a second. Right, so likewise we have the different transformations like date generation, effective date hierarchy flattening, map series, pivot, reverse pivot, table comparisons, right? So this directly will not convert the data, but yeah, they will help you to improve the performance when we are utilizing or they will try improve the capabilities of data migration. So that's about the transformation. Next we have the data store tab. So data store, what is a data store? So data store is nothing but a connector which will allow data services to communicate with the external systems, right? It is kind of a gateway which will allow the data services to communicate with the external systems. For example, you have a source system as SAP, then you need to create a separate data store for SAP source system, and you need to interact with that SAP source system. Next, we have a SAP BW system as your source. Then you need to create a separate data store so that you can read the data from BW system into your data services. Then you have a database system as your target system. Then you need to create a database data store to communicate with that target system. So there are three basic types of data stores. One is your application data store, which will help you to connect with SAP systems or Oracle ERP systems. And the second one is database data store, which will help you to connect with the databases like SQL Server, Oracle, DB2, and all the backend databases. And the third one is web service data store, which will help you to connect with the web services. So these are the three basic types of data stores. One is your application data store, which will help you to connect with the applications like SAP and Oracle ERP. Second one is database data store, which will help you to connect with the databases like Oracle, SQL. So let it be a source or target or the backend databases. You can connect with them. And the third one is web service data store, which will help you to provoke or invoke a web service into data services. And next one is the format tab. So you have sometimes you have data flowing in from your source in the form of a flat file. For example, one of the clients that I worked in the Middle East is into big business, like it is like into the shopping mall business. So, but they have the data in the form of flat files because that's what they maintain. They always entered the data into the Excel sheet and they kind of maintain that. Now they want to migrate into an Oracle system, so they want all the historical data which is present in the form of a flat file. So that was the source. So most of the projects, if the client is like that, or sometimes if the client don't want to give you an access to his source system, so what he does is he exports the data from his source system into a flat file and he will provide you the access there. So in that cases you connect the flat files, let it be a .txt or .csv or .xls file. You connect those flat files with your data services designer using the formats tab. So here you can connect the flat files, .txt files or .csv files. You can connect .xml files. You can connect the COBOL worksheets. You can connect XML schemas. You can connect DTDs, data type definitions. So we can connect different sort of file formats here. And the next one is the custom functions. The functions tab. So this functions will show us the built-in functions. So first let me double click on one function here. It will take me to the function editor window. Okay, this is my function editor window, and if I look at sorry, the box on the left hand side, it gives me all the list of functions that are grouped here. So if you look at the aggregate functions, I have all the built-in aggregate functions. Then if I have the conversions, then I have the cryptographic, then I have the custom functions, then I have the date functions. Right, so I can utilize all these functions within my job whenever required as per the business case requirement. So instead of writing a code there, I can use these built-in functions within my. So you have all this list of functions that are available pre-built within data services. So that's about the local object library, and this is the start page, show page, or we can call it as a start page on data services, which is again divided into three segments. One is getting started. So if you want to open any of the, this is the shortcut for all the remaining tools. So if you want to open a project, you can click on this and open a new project. Then you want to create a new project, click on this. You want to create a data store. So you want to import a flat file. So all these things are your shortcuts, I can say. So it is a getting started page where they gave you quick access to all these different tools, then to your central repositories and management console. And the next part is the references. So if you want to do any postings online to get some answers in forums, you have this forums on Software Community Network, SAP SEN, and the next one you have this data services community, and you have the reliefs, notes, blueprints, technical manuals, and tutorials. And the last part is the projects tab, which will tell you which project was open at what time. So, sorry. So the history is maintained here. So this is a little introduction about the data services designer. So once we start working with this tool, we can understand more about it. So if I just open this job, so the quick page is now converted into my designer workspace where I can actually design my jobs. All right. Okay. So there are a few more tools with data services. I'll take you through them. Right, so this is the navigation, and you have all the tools grouped together in Data Services 4.0. So you have the designer, which we just saw. The second one is the management console. So this tool is a web-based tool which opens with Internet Explorers or Chrome or a Firefox. Generally it opens with a web page, and this is an administration tool. So the reason behind this is an administrator, rather than being on the project site, he can connect to this activities from anywhere, and he can deploy the projects. So he can create the groups, he can create members, he can add members to different groups, he can give authorizations and restrictions, he can monitor the jobs, schedule the jobs, create the jobs or kill the jobs, or he can create auto documentation. He can check the performance of the system by creating job servers, dashboards on job servers. So all these different admin activities can be done using the management console. Next you have the data services repository manager. So this repository manager will help you to create the repositories. So every user who wants to log into the data services designer need a local repository, and we will be doing that from this tool called repository manager. And we also have three different types of repositories. One is your local repository, which every individual requires to log into the designer. For example, there are 10 users in a project, so we need 10 local repositories to connect and work on the project. And finally, once everybody completes their work, they want to upload their work into a common place. which is called a central repository. Again, this central repository can also be created from this repository manager. And the third one is the profiler repository. When we do a profiling activity on any tables, so we need to save the statistics of the profiling repository, the profiling job. So these will be saved in the profiling repository. And the next one is the server manager. So server manager will help us to create the job servers. So when you are creating a job within Data Services Designer, and when you want to execute this job needs to be executed on a server. So we will be creating these servers in the server manager. And next one is the license manager, which will allow you to upgrade your license. So apart from data services, you also have the BI platform for where you have tools like central management console. So you have a management console here, okay, and you have one more called a central management console. All right. So why do we need something like that? You have a management console, again you have central management console. See, management console is exclusively for data services, but if you look at business objects is divided into two categories. One is business objects enterprise, that is the reporting part, and the second one is data services. So this central management console is a common management console, or it's a common administration page for both the business objects enterprise and the data services. So from version 4.0 they made it mandatory that you need to interact with the central management console. In the previous versions it is not mandatory. You can just interact with the local management console of data services and you can create your jobs. But from version 4.0 they made it mandatory that we have to interact with the central management console so that all the repositories that you work on are centrally visible, or you can call it as globally visible for the administrators. Okay, so these are the different tools that we'll be looking at. Okay, so let me just give you a business case. Any questions, Kofi, so far? Is it clear?
I don't have a question now.
Okay, go ahead.
I don't have a question, no.
Okay, you don't have a question? All right. Okay, so now let us see a business case here. For example, I have the data in my Oracle system and my SQL system, and I want this data to be migrated into my final system, which is my Oracle system. All right, so this is my business case. I have two different sources here, and my target system is again an Oracle system. Now the business requirement is I need to migrate the data from both these systems into a single system, and I have a situation here that I have common vendors across the systems, common customers across the systems. So if I dump the entire information from Oracle to Oracle and SQL to Oracle, then definitely I'll end up having duplicates in my data, which I don't want to have. So I want a tool to take care of this deduplication, or a smart tool which can handle all these kind of activities, and it can transfer the data into my target system, right? So you can do that using data services. So data services will take care of all these connectivities and different deduplication activities or joining properties and all these things, and it will load the data into the target system. So first we need to establish a connection between your source system and your target system with your data services, and even before that first we need to log into the data services. So to log into the data services designer we need to have a local repository, right? So every user who wants to connect to this designer should have a local repository, right? So as per the nature of data services, it will not hold even a single record. So where do I create a local repository? So for that you need a backend database, which is generally our SQL server. So in this backend database, what I do is, so generally now we are actually looking at the architecture and how it evolved and how it is designed this way. So in this SQL server, first I'll go and create a database of my own on which I'll be creating my local repository, and I will assign my database to that local repository so that all the provisions that this local repository provides me will be saved within my repository database. So if I might create some users with restrictions, or I might create some authorization grants to my particular local repository. So all these things will be saved in the backend database so that at the time of login, I don't need to, enable all those things. Everything will be saved in the backend database. And for me to connect to the data services designer, I need to have a local repository. But once I create a job within my designer, I need to execute this job. So this job should execute on a job server. So I need to create a job server and connect my local repository with the job server. So that whatever I create within my designer and execute, so it goes to the local repository and it gets executed on the job server. And there's one more thing called management console, central management console. Right. So all the local repositories need to be registered in the central management console so that it's visible for the administrator, like what is happening across the project. So to create the users, so for this local repository I just want to give a developer access, or for the next local repository I won't just give a tester access. So I can do that from the management console. So we need to register our local repositories in the management console. Alright, so now my architecture is ready. So I have a SQL server, the backend database server, on which I built my local repository, and I assign my local repository to the job server, and I log into the designer with my local repository credentials, and I registered myself in the central management console. Now architecture is ready. So how do you connect to your source and target systems, right? So there's a concept called data stores, which I told you, which is available here. So this is the data stores tab, and these are your data stores, which will allow you to connect with the external systems. So here I create two data stores, one to connect to my source 1 and the second to connect to my source 2, which is my SQL and Oracle systems. Okay, so now once I'm done with it, I do my ETL part, extraction, transformation, and loading. And finally, I convert this data into the target required format, and I load the data into the target system using my target data store. So this is what you'll be doing within your data services. Right. So to do this extraction, we create a separate extraction job wherein we pull in the metadata from both the different sources and we try to join them, and we try to create a target structure with the required fields and the format and the order of the fields, and we do some there's a migration methodology which we generally follow, where we do a deduplication, validation, and transformation, and finally load, do a post-load validation or a preload validation on the data, and again finally load the data into the target system. So that is actually called as SAP BPDM, which stands for Best Practices in Data Migration, or it is also called as AIO methodology, SAP all-in-one methodology, which we'll be looking in a little detail. So this is how your data services will work. So we need to create a local repository, then we need to assign the local repository to the job server, register your local repository in the management console, and log into your designer. Create the data stores to connect to your sources and to your target, and you extract the data from the source, transform the data to the required format, and load it into the backend system. Alright, so I'll just come out of this. Now, if somebody gives you a freshly installed system, a new installed system where there is no job server, no local repository, so we need to set up the system. Alright, so first we need to set up the system. Kofi, I'm listening a lot of disturbance. Are you able to listen to the disturbance as well?
Yes, I can hear you.
Okay. So it's actually distracting. I'll just put you on mute and you can unmute yourself. Just let me see if. Okay. I'm making you as the organizer, and you can unmute yourself now. I'll just put you on mute, or just see if there's no disturbance. We can go ahead without even muting, right? So now the question is, so you are assigned to a project on data services, and you're given a freshly installed system. So nothing is there, no data stores, no connectivities, no local repositories, no job servers. So how do you make your system a system which is ready for the project? So how do you set up the system? So this first topic is called setting up the system, which is an administration role. Generally a developer will never do this part. This is an administration role, and my training is designed in a way that, you know, along with the flow, you'll be looking at the administrator activities as well as the developer activities. So we will see how to create a repository, and we will see how to use the repository. So that's the plan, and you'll see how to create a central repository, which is an administrator's role, and you will see how to utilize the central repository, which is the developer's role. So both the admin roles and the developer roles, or what I can say is the architect roles and the developer roles will be covered along with the training. So this is what I can say as a high-level training, but we'll be starting it from the scratch, and along with the flow we'll be looking at all the different activities of an administrator, of an architect, and of a developer. So initially this is an administrator's role. The guy who administers the project should create all these repositories, and he will provide it to the developer, and the developer will generally never know like how his local repositories are created. He'll just log in with those credentials into the designer and he'll start working. So first we need to set up the systems, or we need to make the systems project ready. So for that, the first step is we need to create a database in the backend SQL Server. So you'll be creating a repository on top of database, and all the repository information is saved within your local database, right, which we'll see that. And create a local repository using repo manager. Third step is create a job server and assign the job server to the local repository. Fourth step is register your local repository in the central management console. The fifth step is log in to the designer. Okay, these are simple 5 steps that we need to do when we are creating a local repository or when we're making a system project ready. These are the simple 5 steps that we need to do. So if we compare this with the architecture diagram that we have just seen, first we need to create a database, then we need to create a local repository, then we need to assign the local repository to the job server, then we need to register the local repository in the central management console, and we can log into the designer and we'll have a fresh development instance there. Alright, so to do that, first we need to go to the SQL server to create a database. So the navigation is Start Programs, SQL Server 2008 R2, and you have the SQL Server Management Studio. Same wise, you can have an Oracle system as a backend database or a DB2 system as a backend database. But mostly used across the projects is the SQL Server. I learned that from my experience. So there are a couple of clients that I've worked with. They used Oracle as the backend database as well.
Okay.
Alright, so once you go into this Management Studio, SQL Server Management Studio, we give your username and password. And just connect. Okay, so you expand the databases and you select the database, right click and go for a new database. Okay, I gave the database name as db underscore lr underscore kofi. So is that the correct spelling?
Yes, that's
Yeah.
right.
Okay, so I am creating a local repository database for coffee. So similarly, in a project, if I have 10 developers, I'll be creating 10 databases, but generally there in that project case, I'll never give the names. I will give user 1, user 2, user 3, or developer 1, developer 2, developer 3, and so on, right? So this database, you just need to give the database name and click on OK. And this database is created at the last. Alright, so I have this database created. So my first step is done, right? Creating a database in the SQL Server. Next step is creating a local repository using the repository manager. For that, I need to go to this navigation, Start Programs, Data Services, Repository Manager. So as I told you, this repository manager allows me to create 3 sorts of repositories. One is local, which every individual requires to log into the data services designer. The second one is central repository, which will be a common storage, a Z drive sort of thing for all the different developers. And third one is a profiler repository where we'll save the statistics. As of now, we'll be looking at the local repository, right? And the database type. So you can have these backend databases, DB2, Oracle, SQL Server, MySQL, and Sybase. So we have SQL Server. Now you have to give the SQL Server name, the database name that we have just created, the username and password, right? So I need to give the database server name. So this is my database server name, PODS server. This is the server name. So I just copy it and give it here in my repository manager, right? So I gave my repository type, the database type, the server name, the database name, username and password. So you can directly go ahead and click on create to create your local repositories, but there is a precautionary step that we generally take when we are working on the project, because if you look at the projects, you'll not have an access to go and create your databases. You need to raise a request for that, for the system admin or the DBA to create a database with so-and-so naming credentials and provide it to you so that you can start working on that and create a local repository. So in that case, there is a possibility that due to some typo or something, he can provide you a database name which is already utilized for some other local repository, and if you just click on create, what are the information that was saved on that particular local repository or on that particular database will be dropped and recreated. So that means you lose everything. So to avoid such sort of activities, you just click on get version first, and it says that the database exists but the repositories are not valid, right? So if you look at this, right, so you don't have any tables that are related to the repository. You just have the system tables and everything as empty in your database. Now that's what it's saying. The repository tables are not valid. Now once I create this local repository, all the repository tables are added to your database so that they'll take care of all the authorizations or all the amenities that are required for you to work with this tool, right? So once I click on create, now you can see adding data quality, installing the calculation usage dependency, adding XML template format, adding system functions. So it will add all the different transformations or all the different activities to your local repository so that it will cross-check every time you log into your designer, see that what all the different authorizations this particular guy has. Now it says the local repository was successfully created. I click on get version to see it says that the local repository version 14.0, which is like for 4.0 it's 14.0, for data services 3.2 it's 12.1.1. so this version is available. Now that's the difference, and I just will close this. I'll select the database and I'll just refresh, and now I expand the tables and you have all these tables created under your database. So all these tables will help you to log into the designer and start working. This has all the repository information, and one suggestion, even by mistake, do not delete even a single table from this backend database, because even one single table deletion will cause your data services repository to be crashed. So do not touch this. It's always better, or it is always suggested by SAP best practices, that you use a separate database for repository and separate database for remaining activities, like to create your staging areas, to create your intermediate tables or intermediate calculations and all those things. Use a separate database. Do not use the database which you have created for repository creation, because these databases have a threshold. So some databases are designed in a way that they can handle data up to 4 GB, and every time you create a job, every time you create a data store, all these informations are saved within your database at the back end, and once it crosses that 4 GB limit, then automatically it will get crashed. So do not use the database which is used for the repository creation for any other purpose, and do not delete any of these tables, because doing both will crash the repository. So now we created two steps. One is created the database, and the second one is created the local repository. Now the step 3, create a job server and assign the job server to your local repository, right? So the navigation further says start programs, data services, and server manager is a place where we create the job server. So click on server manager. Alright, so this is a very small pop-up window here. Right. And you can click on configuration editor under the job servers. So there are remaining things which we'll look at a little later. So as of now, just look at the job server. So click on configuration editor and you can see all the existing job servers and the ports assigned to them. Right. So what you notice here is each and every job server has a different port number. Right. It has a unique port. So a same port number cannot be given to two different job servers. So each and every job server has a separate job server port. So generally what happens in a project is like you create one job server and you assign all the local repositories to that job server. Or you know that the pressure on the job server will be more, Then you create a job server group, means you create more than one job server and bundle them into a group, and you give an access to the backend developers to that particular group, so that if one particular job server is overburdened, then automatically it switches the burden to the next job server. Alright, so here there are multiple job servers that we have created. So we need to give a unique port number. Alright, so to add a new job server, click on add and give the names JS underscore for LR underscore KOFI. So I'm giving the job server name as job server JS underscore LR underscore KOFI. So you will be seeing or noticing that I'm very particular about the naming conventions, because once you go into a project and start developing your jobs are invalid unless and until you follow a proper naming conventions and do proper documentation of the job. Because definitely on huge projects at the SAP level, they will definitely consider the documentation as the primary thing, and everything should follow the naming conventions, so you have to do that. So I am creating a port number like 3555. I think it was not used, and you just click on add. Now you gave the job server and the job server port name. Then enable repositories, just click on add. So you have the database type here, then the job server name. You can copy this BODS server from here and paste it here. Then the database name, the database on which we created a local repository, so copy that and give it here. Then the username and password, and just click on apply, and this particular local repository is now assigned with the job server. Right? If you want to do some changes, you can select that and edit and give the password here, and you can do some changes there. Or you can delete this repository and you can make this repository as a default repository for this particular job server. And you have something like SNMP communication, which we'll be looking at a little later, where your job servers will interact with the message types or message formats. And just click on OK. Now your job server JS underscore LR underscore coffee and the job server port name 3555 is available. Right, now you don't have a button like close, OK, cancel. You don't have something like that. So you have something like close and restart. So what does this do? So if I click on close and restart, it will say this will restart the data services on the machine. Right, so which means it is restarting the services on the machine where the job server is installed. So where do we find that? So you go to your control panel and administrative tools, you have services, and all the different services that are helping the system to run will be available here. So these are the different services which will run your system. So if you look at these services, you'll have something like business objects data services, which is started. Right. So me clicking on OK here will restart this particular services. So let me just refresh. So now you see it is stopped. And now it is starting. It started now. Right. So this job server, once it is done, it will restart the services on the system where the job server is installed, so that the newly added credentials or newly added repository is totally registered with the data services designer. Right. So we are done with the step 4 or step 3. Now we need to go to step 4. Register your local repository in the central management console. Right. So the navigation for CMC is start, programs. Now we will not go to data services, because in data services you have just management console. So you need to go to central management console. That's the difference from the version 4.0. So this central management console opens with a web page. Alright, so I give the credentials here and click on OK or log on, which will take me to the home page of Central Management Console, where I have data services in the left bottom corner. I can click on this, or from the drop down, these are sorted alphabetical in alphabetical order. I can select data services. Right, so now I am under repositories. I'm in repositories of data services. So just let us click on this repositories to show all the list of registered repositories within the data services designer. Right, you see all these repositories. So you have the descriptions, HANA repository, BODS server training, then profiler repository, you have central repository for the month of May, then you have data services training repository, HANA repository. So there are different repositories. Now our repository which we have created is not a part of the central management console. So we need to add that. So to add the repository, you can click on configure new data services repository. Click on that and give the name LR_KOFI, then give the description local repository. Sorry. Then the database type is this Microsoft SQL Server. The host name means the database server name is BODS server. Alright, so I'll copy that and give it here. Then this port name is a unique port, so there's no need for you to change that. It will be the standard this thing. And next one is your database name on which you have created a local repository. Then is this you require a Windows authentication? No, there are two modes of authentication. One is your SQL authentication and second one is your Windows authentication. So we'll go for a SQL authentication, so that you have to give the username and password here. So I gave the username and password. And the last question is this a profiler repository? No, it's a local repository. So when we are looking at the profiler repository, we can see that. So once you key in all these credentials, you have to click on test connection. So it will try to communicate with the backend database and all those things and tell you that it is successfully connected to the repository. That's perfect. So click on save. Right, now your local repository is added, right? So this is your local repository is added to the BODS server. So step 5 is also done. Step 4, registering your local repository in the management console, central management console is done. And next one is step 5, log into the designer using your local repository credentials. So the navigation is start, programs, data services, designer. So now this will take me to the log-on screen where I have to give my credentials, the username and password, and I have to select the repository on which I'll be working. Right, just click on log on and it will show me the repository that is created for you, L_coffee, and local repository for coffee. Alright. So now this will take you into a fresh designer instance where you'll not have anything, like you don't have a data stores, you don't have any projects created, you don't have any jobs that are available, you don't have any data flows, everything is empty. This is a very fresh instance that we have just created. Right, you don't have any flat files added. And from now the developer roles will start till now what we have seen, this 5-step approach, is the administrators or the architect's role who will be creating or setting up the system. And once this is done, then what we do is generally we provide these credentials. So we'll not tell the developer like how we are doing all these things at the back end. We'll just give them the credentials saying that, hey, this is your username and password, and once you give the username and password here, you need to select your respective repository and log into the designer and start working, right? Alright, so now let us see a small scenario, one more business case, right? So I have the data in the form of a flat file and I want to load it into another flat file. So why from one flat file to another flat file? There will be different business cases why you need to do that, because sometimes you don't need to have all the columns that are present in your source, or sometimes you need to filter the data and take the required data to the other side. So you can do that on the Excel, filter that and copy and paste, but let the system do that. Why we want to do that? So you can do that flat file to flat file extraction. So we'll see this first fundamental scenario for today, and we will try to conclude the class. Okay, so it's flat file to flat file extraction. So a developer logs into the designer, and it is his fresh scheme, and there's nothing available here. So the first thing that he needs to do is create a project. So create a project so that he can group all his jobs together. So I can click on this shortcut icon here, create project, so that I can create a project, or I can click this one, Control N, or click on this one to create a new project, or I can go to projects, I can go to new and create a project here. So anyways, you'll be creating a project, so just go for the simple way. So I can So I'm calling this project as project training. Click on create. Now you can see this project available under your project area as well as your local object library, right? Next one is you need to create a job. But before I create a job, so let me put it in the notepad for the flat file to flat file extraction. So if there is a project, this is optional. First time when you are working with this, if there is no project, you have to create a project. If a project is already available, there is no need for you to create a project. You can utilize that one. Second one is create connections to source and target flat files, right? The third one is create the job to do ETL, right? It's a 3 simple step process. First we need to create a project, that too it is optional, and then you have to create a connection from the source file or the target file to data services so that it can read the data and write the data into this source and targets respectively, and then create a job which does the extraction, transformation and loading. So now first we need to identify a source file, right? So I think I have them in my D drive. Right, so I have some source flat files here. So let me take this customers. So I need to add this customers. Okay, so this is the data that I have here. I need to add this customer information into my data services system, and from this Excel file I want to write it into a .txt file, right? So let us take that as the business case and save. So go to your data services designer. To connect any flat files you need to go to formats. So click on formats, And based on the file type, if it is a .txt or .csv file, you can go to files, or if it is an XLS file, you can go to Excel workbook. So select the workbook, sorry, right click and go for new. You can do it this way, or you can right click in this white area and you can select new, and you can go for Excel workbook. This is way 2, and the way 3 is go to projects, go to new, and you can go to Excel workbooks. So there are 3 different ways in which you can add an Excel file into Data Services Designer, right? Anything will take you to the same screen. So I can call this as source underscore, or let me put it a proper naming convention, FF underscore. FS stands for flat file, source underscore customer. Right, I give the same file name. So first let me select the directory from where I am trying to take it. So I need to select folder here. One second, my system. Okay, and I need to select the path from where I am trying to read. So it's not on my desktop, it's in my computer D drive. So I go to my computer and I go to my D drive, expand that, and I'll go to my source flat files. Click on OK, and I'll select the file from which I want to read the data. So that is my customers file. Click on open. So remember, data services will support only .xls format, which is like 97 to 2003 Excel format. It does not support XLSX, which is the latest version of Excel. So you need to convert the data into .xls format or .txt format before you try to attach that file into data services. Right. Now, I gave the file name, I gave the path from where I'm trying to read this file, and I selected the file. Next one is the worksheet. From which worksheet you are trying to read the data. So the customers is the worksheet name, and I want all the fields and code page. So why do we need code page? Right. So if you have some different fonts, or if you have different accents that are present in your data, so we go and select the different code pages that select. So UTF-8 or UTF-16, these are the 2 code pages supported by SAP to understand the SAP data. So for example, you are extracting the data from a flat file and somehow the system is not able to support that. So you can go and change the code page to UTF-16 or UTF-8 so that that unsupported structure or unsupported format of data is supported now. So as of now we are going to take it as none and use the first row values as the column names. So the first row of your Excel sheet or the text file has the headers, so you can check this box to use them as your column names. Once you check this box, click on import schema and it will try to import the metadata of the source structure. So what is metadata? Metadata is nothing but this: the data types, the lengths, the number of columns, and all these things. The information about the table. So generally when we take the bookie's definition for metadata, we just read like the data about the data. So this is the data about the data, the information of about the table, the structure of the table. We consider that as the metadata. So now the metadata is read. You can just click on OK and you can see this flat file attached to your data services. Now similarly, let us create a flat file to which we need to write the data to. So select the file, right click and go for a new. You can do it that way, or right click, go for a new and select a file format, or go to projects, go to new, and you can select a file format here. right? So the simplest way is like select the flat files, go for new, and give the file name ff underscore trgt underscore cust target customer, and I want it to be saved on the local location, so I just keep it as local. And the second location you have is the job server. So you can save the flat file in two different locations. One is to your local to your system, and the second one is a folder on the job server. So I will try to save that in my XML Kout folder, DL folder, right? And the file name that I want to give it as ff underscore customer txt. Then it is the delimiter. We can select if it is a tab delimiter, semicolon delimiter, comma delimiter, or a space delimiter, or you can give the separate symbols like a pipeline delimiter and all. You can give it. So just let me give it as a comma delimiter. And the next row is a Windows new line because it is a .txt. It is a new line for Windows. And if it is a CSV, it is just a new line. Then skip the row headers, no, yes, and write the row headers, no. So just click on save and close, and your target file is ready. So the connection to your source file and your target files are available. Now let us create a job. So how do we create a job? Again, right click, go for a new job, or you can go to projects, new, and you can create a batch job. So now I told you that if it is a structured information, we'll be dealing that with the batch jobs. So right click and go for a new job, and the naming convention for the job is job underscore ff underscore ext, right? I'm trying to do a flat file to flat file extraction now. So if you look at this, under a project, I'm creating a job, and under a job I can create a conditional, I can create a workflow, I can create a data flow. So the least node that you can create here is a data flow. So I'll show you that chart tomorrow, like the hierarchy, and once we start working with the tool, you know, from the basic level to the next level, so we can start utilizing all things. So as of now, just keep in mind the last node that you can add within a job is a data flow. So I call this as df underscore ff underscore ff ext. So the naming convention for data flow starts with df. The naming convention for job starts with job. Right. So now I select my source flat file and drag and drop it into my designer, and just click on the icon magnifying glass to see the data. So it shows the data, and there are like 49 records that are already available in your source. Now you select your target flat file, drag and drop it into your designer, and make it as target. Now you connect your source directly to the target, because now it is a one-to-one extraction. We are not doing any filters on this. So once you are done with the design, I'm done with my design. Technically speaking, I have my source, I have my target, which I am connecting with my source, and I have created my jobs, everything. So now you need to validate the syntax. So you can click on validate all to see the syntax if there are any errors. So, or you can click on validate. So what is the difference? Validate, if you are within a data flow and you want to just validate that, you can click on validate. And you are at the job level and there are multiple data flows available here, you can just click on validate all. Right, so now I want to execute my job. There are again 3 ways. You can select your job and click on execute on the menu bar, or you can press F8 on the keyboard, or right click and execute. Right. So now it is asking me to save the changes for the job and the data flow that we have just created. Click on yes. And this is the execution properties window, which has the global variables, parameters, traces, and options, which will look a little later. But as of now, the sample rate is 1000 records, and we are working on the job right job server. right? So this is the port number that we gave. Click on OK, and now your designer canvas is now converted into the monitor tab. And here you see 3 logs. One is your trace, second one is your monitor, third one is your modeling. So in the trace, it will say you the step-by-step execution of the job, which means this is the repository version. Then this is the current job directory, and this is starting on the BODS server, and this is the job name that is starting with the run ID. Right, so in SAP BI, I think if you know that, you can understand, like everything that we create will generate a request at the back end so that we can track those changes using those requests. Similarly, every job that we run on the data services system will create a run ID, and it is initiated by the user administration. So first it is processing the job, then it is trying to optimize the performance of the job, and next the job is started. Next, the data flow is started. Then once the data flow is started, as I told you, data services does not have a memory of its own. It utilizes the cache memory. So it tries to search like what memory is available on the cache, and it utilizes that one. And the data flow is running in the cache, and once the data flow is successfully completed, the processing of that data flow is completed and the job is completed. So this is the log. So if you look at the job execution timestamp, so 7:54:28 a.m. is the job starting time, and 7:54:35 a.m. is the job ending time. So the job is completed in 7 seconds. You can see that in the monitor as well, right? So 5 odd seconds is the absolute time for the job to complete, and actual extraction of 49 records is done within 0.115 seconds, and writing them into the target file is done in 0.011 seconds, which is like nothing. So this is a small count, but when we deal with more records, you can see the performance of data services. You can write 10,000, 15,000 or 20,000 records in less than a second, or it depends on the database from which you are extracting. Sometimes it writes in less than seconds, but when everything is present on the same system, or if your source is some separate machine and your target is separate machine and you are trying to use BODS, at the time it might take some time because it is literally sending the request and response to different machines at the back end. And this is the warnings tab. So this either gives you the warning or an error message. So if it is an error message, it will turn to red. Now your job is successfully completed, which means you wrote the data from this flat file into another flat file. So now let us go back to the database and see. Alright, so this is my source flat files, XML, Kout, and DL. So this is the path that I gave, and FF target customer is created. Now if I open that with a notepad, right, so I have the comma separated data available here. So to put it in the right format, just copy this, go to any Excel sheet, right, paste it, go to data, text to columns, then it's a delimiter separated, it's a comma separated one. Just click on next, select till the last column and click on finish, and now you see the data is now again converted back into the normal format, right? Alright, so this is how we extract the data from a flat file to a flat file using data services. So going ahead, we'll be looking at different scenarios when we extract the data from a flat file and write it into a database, or extract the database from data from the database and write it into a flat file, right? So we'll be looking at all these scenarios in next classes. So any questions in today's class, Coffee?
No question.
Alright, so we'll catch up tomorrow at the same time and we will discuss more, right?
All right.
Have a good night.
Thanks so much, Sano. You have
Right,
a good
man.
night. All right.
Welcome. Thank you. Bye.